See, as a part of public key distribution, the only challenge which we have is how to share public keys to everyone in our network. So that is what this slide is about to, this presentation is about to discuss. Now, the outline which we are like, in how many ways we can share our public keys into the network are, there are 6 main types. We have 4 main types. Out of these 4 main types, only 2 types are very, very important. The first 2 types are having a number of attacks. So from first one to next one, how we are moving, let us see in detail. And the last 2 in this are, the first one, 5th one is nothing but how to maintain your certificate in a proper way by using the, after having your signature, how to maintain this certificate properly. So the format will be given by X.509, and PKI is the total infrastructure of this environment, how this public key distribution can be done, right? So the public announcement is nothing but if there is any user who wants to communicate in the secure channel, they will be created with the public and private key combination, and private key will be with Bob itself, which is confidential to them. Now, the sharing of public key is important in the public key encryptions and also in distributions point of view. Now, when Bob enters into the network, he starts publicly announcing his public key to everyone. So this is user 1, user 2, user 3. So like this, if we have n number of users, to all the users, we start sharing the public keys. That is nothing but announces a public key. So, but when we have this type of thing, if any intruder is there in between as one of the authenticated user, then even that person also will be getting your public key directly, which is not secure, right? So the announcement of the public keys publicly is not secure, right? So for that reason, we are moving to the trusted center. In the trusted center, the only difference which we have is we will maintain one center as similar to the KDC, key distribution center in the symmetry. We maintain a trusted center here where all the users of that particular network will be storing their name, the subject name with the key, public key. Subject name with the public key. So when I say subject, that indicates that the user details. Now we'll have the user details and it's their public key. Now, as a part of communication, Alice was to communicate with Bob. So the directory is ready with all the users' public keys. Now trusted center will search for Bob and it will give the public key to Alice. So this is also okay, but there is a more somewhat secured than the public announcement. Now, as this center is not properly secured, directly this is accessible to everyone in the network. See this, even though this is a separate directory we have in the key pair combination, even though this is trusted center, this is available to everyone in the network. So in this network, somewhere we can have Eve, who is an intruder, right? So for this kind of things, we are moving to the next version, that is control trusted center. So in the control trusted center, we are providing higher security than the trusted one. So what we are doing is whenever any new user enters, so instead of directly saving, this user will be saved into, as an authenticated users, these users will be giving their public key and their subject name, to the trusted center. Now, when users want to communicate with each other, they will be requesting for the public keys of that particular receiver, right? Previously, every user will be having access to this. Like if Alice want to communicate with Bob, now Alice will be communicating with trusted center and they can take Bob's public key directly and they can communicate. But here, that is not the case. Here, what we are doing is, even though they are authorized users, Alice will be requesting for Bob's public key with few timestamps. So within 20 seconds like this. So this timestamp will be very important. Now, when trusted center accepts the request and analyzes that Alice is the authorized user, then trusted center will take Bob's public key and it will be signed by this timestamp and it will send to Alice. Now, Alice will be taking this key of, public key of Bob by utilizing their own public key of the trusted center. See, why we are saying public key is while trusted center is sending the public key of Bob, the trusted center will sign that with private key of the trusted center. TC will be utilizing, trusted center will be utilizing its private key to sign that Bob's public key and it will send. So as Alice, as a authenticated person, he will be having public key of trusted center. So he will decrypt that and he will get Bob's public key. So this is a controlled trusted center to exchange public keys to the sender and the receivers. Now the fourth one is here in the previous one, here we have proper security, but we don't know whose public key we are sending. In between something might be happened and instead of Bob's public key, we may forge this one and we can place Eve's public key here. So even though it is trusted center, sometimes we can have access of this also. So to overcome this kind of forgeries and all, we must go with the certification authority. So where certification authority will be giving access of all the public keys publicly with no forged public key concept. So this CA is nothing but it's a state organization that will be having all the entities where it can provide a certificate onto your public key. So even though if you are having a public key, that public key must be signed by CA so that no other users or no intruders, adversaries can forge your public key. In place of my public key, if other sender gets some attacker's public key, then everything collapses. So that is the reason CA will be responsible for issuing of the certificates onto your public key. So which is signed by CA's private key. This is very important point. So who will be signing the certificate while sending this public key is CA will be signing a user's public key with the certificate by private key of CA so that the problem of public key fraud can be reduced a lot. Okay, so the main intention of certification authority is to reduce public key fraud. So how means we are going to issue a certificate by utilizing CA's private key to sign that, right? So here this is the procedure. All the users' public key will be available in the trusted center. So before giving, see Bob is applying to store his public key onto the trusted center, right? So before storing that, what CA will be doing is they will take Bob's public key, then CA will sign that public key with CA's private key. So after signing properly, so this is signed public key by CA's private key. So that will be stored in the trusted center. Now, whenever any user asks for this public key, we will get Bob's certificate signed by CA. Okay. So this is not a normal public key of Bob's public key directly. Whenever any user like Alice or somebody is requesting for Bob's public key, then CA will take this access, request. Then it will take public key of Bob and it will sign by its own private key and send to the Alice. Now, Alice will be having CA's public key, right? So CA's public key, so it will decrypt that. It will unlock that and it will start utilizing Bob's public key for encryption or decryption procedure. So this is a certificate authority job, which is reducing public key fraud a lot in the day-to-day lives to maintain our channel very secure. Now, X.505 is a certificate protocol. I mean, it is a format. So X.509 is a format how to maintain your certificate. See, a number of CS will be having their own style of providing certificates. So as we have universal cases everywhere, so all the certificates must be in the same format, right? So different users, I mean, different certificate authorities may provide different formats of certificates. So which is not a proper format, means a proper CA1 has been utilized with one certificate, means CA2 cannot recognize what is this certificate and what is this certificate. So that's ITU has been designated, I mean, designed with one of the format to maintain common format for all the certificates, right? So this is a certificate format. X.509 is a certificate authority format where it is following same fields, same format for all the certificates provided. So this is having the protocol, that is ASN. So this ASN is nothing but abstract syntax notation, where it is having the same format throughout the universe. The fields a certificate may have are the version, serial number, I mean the unique number of that certificate, algorithm information, means which algorithm we are utilizing to sign that particular certificate. So this is what the signing algorithm is. Next, issuer distinguisher, means who is providing the certificates. Validity of this certificate. Subject distinguished, means who is the user here. Here, who is providing the certificate. So CA is providing the certificate, and to whom we are providing, to Alice we are providing. So subject name here and issuing authority here. Next, public key of the Alice. Issuer unique identifier is optional when many certificates are provided by CA1. So in that, again, we have to have a hierarchy of this, right? In the CA1, this is 1.1 version, then to other one, 1.2 version, like that. Okay, so subject optional. Next, extensions, if any, for the future purpose. And finally, we will sign that certificate properly, and then we will send to the other end as a certificate, right? See, this is a certificate format. So as we discussed, everything just now is okay. Now coming to the signature. Signature must be followed with the one hash. I mean, the public key and everything will be given to the hash function so that a digest will be generated. This digest will be signed by CS private key and stores, I mean, gives us a certificate to the other party. So this is very, very important format to be known for the certificate format. And the last one is certificate revocation. See, certificate revocation is needed when we misuse our certificate, or else some intruder has been taken our certificate, so there is no validation there yet. So all this type of things need revocation. So this revocation will take place with one common point, that is from when to when. I mean, the validation is important, and how many times we have revoked our certificate is the other part. So this is a revocation procedure. And last one is the public key infrastructure, where all the format of public key distribution will be maintained here. With this has been created by IATF, okay, Internet Engineering Task Force, and this format procedure is called as PKI X.509. We call that as PKI X. Now PKI is responsible for providing all this, means it can provide renewal, revocation of the certificates, and it can store all the keys. It can provide many services from other protocols and too many protocols. So finally, it is a whole and sole access control of all the public key infrastructure. So if you have any doubts in this, please be free to contact anytime, either in the college or through comments. Thank you.